Madunggan ako ninyo class.
Yes,
Okay, so for our first example, we have here this problem. So we have a particle. Particle moves in a circle with radius circle with radius equal to 1.5 meter. So the question is, through what angle in radians does it rotate if it moves through an arc length of 2.5 meters. And then what is the angle in degrees? Okay, so we have here a circle with radius equal to 1.5 meter. And then we are asked to find the angle in radians and in degrees. The particle in the surface of the circle, or area, does it rotate if it moves to an arc length of 2.5 meter? Okay. So if it has moved by an arc length, so this one, say this is your R. In red, this is S equals 2.5 meter. Okay, so we are to find the angle between the initial position of uh, the particle and then katong yung final rotated nga location after the rotation. So for this, you just have to recall the relationship between the arc length and uh, the angular displacement. So we have S equals R theta. Meaning to say, theta is equal to the ratio of the arc length and the radius. So we have 2.5 meters divided by 1.5 meter. So this is approximately equal to 1.67 radians. Okay, and then after this, we will convert this angle into degrees. So take note that we have pi radians is equal to 180 degrees. Okay, so theta in degrees is equal to 1.67 radians multiplied by our conversion factor. We have, so pi should be written in the denominator and then 180 degrees in the numerator. So we have 1.67 multiplied by 180 divided by pi. So this is approximately equal to 95.7 degrees. Okay. And then for our second problem, we have this. So initially a ball has an angular velocity So we are given with the initial angular velocity of the ball, which is equal to 5 radians per second. And then it is moving, or it is rotating counterclockwise. And then after sometime later, so after rotating through a total angle of, we are given with the change in the angular displacement, which is equal to 5.5 radians. The ball has an angular velocity of 1.5 radians per second. And then it is directed clockwise. So it is now moving in the reverse direction after some time. Okay, so the question is, or these are what we will be looking for. So what is the angular acceleration? And then what is the average velocity? And then how much time does this motion take? How much time did this take? Okay. And then for letter B, we are asked to find the angle. So at some point, the angular speed, thank you. Okay. So take note that the ball reversed its direction. So initially it is moving counterclockwise, and then it has then reversed its path. Nag-move na siya clockwise. So at some point, the angular velocity of the ball had to have a zero angular velocity. So the question is, at what angle from and how long did it take? Okay, so here is the picture. So we have a ball initially rotating in the counterclockwise direction. So padulong dito with an initial velocity, angular velocity equal to 5 radians per second. Okay, so suppose this is our this is the initial position of, or the initial orientation of the ball. So take note of this. After some time, kini siya nga point diri kini siya nga dot diri most likely kay naa na siya diri. Okay? So nag-move siya counterclockwise, muna siya iyang path nga gitake, and then at some point its angular velocity has reached zero. So before it has reversed into the clockwise direction. Okay, so this is the initial position of the ball, uh, this point on the ball, and then after some time, ni-reach ang zero ang angular speed and then it has reversed its direction. And kini siya nga point kay naa na dayon siya diri. Okay? So this is where omega final is. This is equal to 1.5 radians per second. Okay, so let us see what are the given. So the given, we have the initial angular velocity, which is 5 radians per second counterclockwise. So take note that in the video, we have discussed there that if uh, the rotation is counterclockwise, then that means it has a positive angular velocity. And for the final angular velocity, we have 1.5 radians per second, and it is moving in the clockwise direction, so it must be positive. Okay, so this is our convention: counterclockwise, positive; clockwise, negative. And we are also given with the change in the angular displacement, so we can write that as delta theta, which is equal to 5.5 radians. Okay, so this is your delta theta. So from this, suppose this is the center of the circle or the ball, sorry. So kung kini siya nga point ato ang i-consider, 5.5 radians is gikan diri sa atong initial na orientation sa ball. And then, kung asa na padulong ning point nga to ang gilantaw. Okay? So, take note that the ball is rotating. So, kung mag-rotate ang ball, kining point nga na diri, after some time, kinani siya diri. Okay, so this is your delta theta, which is equal to 5.5 radian. Okay, so for letter A, we're asked to find the angular acceleration as well as the average angular velocity and the time, the total time for the motion to take place. Okay, so for this, we'll be needing the kinematics equation, the rotational kinematics equations. So since we are not given with the time, so what we'll be needing is an equation that does not involve time. So to find the angular acceleration, so we have this equation: omega final squared minus omega initial squared is equal to 2 alpha multiplied by theta final minus theta initial, or this is just delta theta. So manipulating this such that alpha will be isolated. So we have alpha is equal to omega final squared minus omega initial squared divided by 2 multiplied by theta final minus theta initial, or we can just write delta theta since the change in the angular displacement is given. And then after this, we will just have to substitute all the given. So take note that the final angular velocity is negative. So it's negative 1.5 radians per second squared minus 5 squared divided by 2. And our delta theta is 5.5 radians. Okay. So this is This is approximately negative 2.068 radians per second squared. Okay, so we now have the angular acceleration. And then to find the average angular speed, so we will just use this equation. Omega average equals omega final plus omega initial divided by 2. So the final angular velocity is 1.5 radians per second plus we have 5 radians per second divided by 2. So this is 3.5 divided by 2. It's 1.75 radians per second. Okay. And then lastly, we have to find the time. So the total time, t, in order to find it, we can use any of the three equations, kinematics equations involving time. So we can use this one. So we have theta final minus theta initial is equal to 1 half omega naught plus omega final multiplied by t. So this is just equal to your delta theta. So the left hand side of the equation is just equal to your delta theta. We can rewrite this as delta theta is equal to 1 half omega naught plus omega final times t. And then isolating t, we have t is equal to 2 multiplied by delta theta divided by omega naught plus omega final. So we have 2 times 5.5 radians divided by, this is 3.5, negative 1.5 plus 5. So this is 11 divided by 3.5, which is around approximately 3.14 second. So the total time for this, so kini siya nga trip. So from the initial orientation of the ball, padulong diri so this took 3.14 seconds. Okay. And then for letter B, we are asked to find the angle. So from the original orientation, hangtod nga na zero ang iyaang angular speed or angular velocity. So ikan diri, padulong diri So expectedly, as you can see from this image, yung siya nga figure class, your delta, your change in the angular the displacement should be greater compared to this one, kaning 5.5 radians. Okay? So, in order to solve for the change in the angular displacement, so equation atong gamiton. For letter B, to find, pwede siya nakaisulat as delta theta prime. So for this, we need to set our final angular velocity to be equal to 0. Okay? So this is the angular velocity before it reversed its direction. Ito. So we have now the initial, the final angular velocity equal to 0, and then the initial velocity is 5 radians per second. And then we also have the angular acceleration now, which is equal to negative 2.068 radians per second squared. So we have obtained this in the previous slide. Okay. So, maghapon na kapula. So we will be using this equation, omega final squared minus omega initial squared equals 2 alpha times delta theta prime. Okay. So we have delta theta prime is equal to omega final squared minus omega naught squared divided by 2 alpha. So our omega final is 0. Dili siya 1.5 ha. Dili siya negative 1.5. It's 0. And then this one is 5 squared divided by 2 multiplied by negative 2.068. So this is negative 25 divided by negative 4. So this is 6.04 radians, which is greater compared to katong given nga delta theta. Okay, and then finally, we will calculate the time. So, sa man siya nga time class. Kaganina, nag-calculate tag time na. So, in the previous item, ang time na itong i-calculate is the total time. So, gikan sa initial na orientation sa imong ball hangtod sa katong nag-reverse na siyang direksyon. But this time, kini siya nga time is gikan sa initial orientation sa imong ball hangtod nga nag-zero ang iyang angular speed. Okay? So, T can be obtained using this equation. So, we have omega final equals omega initial plus alpha times time. So, manipulating this, we have T equals omega final minus omega initial divided by alpha. So, we have 0 minus 5 divided by negative 2.068. Okay, so this is 2 point something. So it's 2.42 seconds. Okay, so it's 2.42 seconds. All right. So, do you have any questions so far? Clear enough? So, let's proceed to the next example. Okay, so for the next example, okay, so we have here a problem. Natay 3-point masses lying on a flat frictionless surface that are connected by massless rod. So this is our third problem. So we have 3-point masses lying on a flat frictionless surface. Connected Okay, so determine the angular acceleration of the body if the body is rotating about an axis through point mass A. And then another case is, okay, so about an axis through point mass A, and then uh, and out of the surface, out of the surface. And then the other case is about an axis through point mass B. Okay, so express your answers in terms of F, L, and M. Okay, so here is the system class, muna siyang system. So we have point masses, the point masses. So say for example, this is point mass A. This one is point mass B. This one is point mass C. And they are connected with massless rods. Sorry. So they are connected with massless rod. Rod meaning to say dili siya ma-bend. Okay? So for the first case, so we are given with the mass of point mass A, it's M. Ang mass ni point mass B is 2M. And the mass of point mass C is 3M. And the distance between A and C is 2L. So this is the length between point mass A and point mass C. And then your point mass B is in the center of the two. So this is your point mass B, meaning to say the distance between B and C is L. And then the distance between A and B is also L. Okay. So, first case, we have kini siya nga system daw is rotating about an axis through point mass A. So, naa diri ang ato ang rod. And then, natay force nga gi-apply diri causing this to rotate. So, the force denoted by F. So, kung, for example, imagine na class nga na diri inyo ang axis, na diri inyo ang para mas ma-imagine siya ninyo, butangan ni siya na stick diri through point mass A, wherein pwede maka-rotate about that axis ang imo ang system. So, this is now our whole system. Okay, na-imagine na ninyo? So, through here, pwede siya maka-rotate. Since dito padulong atong force, most likely it is rotating counterclockwise. Alright. So, for this, ato approach is to find first the moment of inertia. Okay? So, the moment of inertia ay sa nakay mga point masses can be equal or is equal to the sum of the individual inertia, moment of inertia sa each point mass. Nakay M, I, R, I squared. Okay, so i-sum up lang siya nato. Therefore, the moment of inertia for this system, since na siya tulo ka point masses, is equal to M A R A squared plus M B R B squared plus M C R C squared. Okay, so for the first system, System 1. So, ganing si System 1 or System A na lang. System A, kay ang iyang axis, ang atong axis of rotation is through point mass A. So, diri siya mo rotate. Okay? So, our moment of inertia, we label it as I sub A, or we denote it as I sub A is na kay MA So yung mass ni A, M nga dako, no? Multiplied by R sub A, or this is the distance gikan sa axis padulong kay A. So in this case, since imong axis kay na ay para siya sa point mass A is ang iyang R is equal to 0. R sub A is equal to 0. Plus your MB is 2M multiplied by the length gikan sa axis padulong sa imo ang point mass B. So this is L squared. And then plus MC. So your MC is 3M multiplied by RC squared. So your RC is gikan diri padulong diri, so that is 2L squared. Therefore, your IA is equal to 0 plus 2ml squared, 2ml squared plus, you have 4l squared times 3m, so this is 12ml squared. So the moment of inertia for the system A is equal to 14 ml squared. Okay, and then for system B, the same naghapon atong inertia since naamang gihapon tayo tulo ka point masses. So I sub B is equal to MA. So we know that MA is M. Now, atong R sub A now is not equal to 0 since for system B, naadiri ang ato ang axis. No? Naadiri. So, diri siya mutuyok. Kung patuyokon ni siya na to class, kung patuyokon ni siya na to, kung naana diri si C, si A, kay naana po siya diri. Kung naana diri si C, naana diri si A. Okay? Since naman siya sa tunga-tunga nilang duha ang axis. Alright, so na kay M, ang distance ni gikan sa axis padulong sa A, ang distance is L. So na kay ML squared plus MB is 2M, R sub B is 0. Plus your MC, 3M, multiplied by RC squared. So your RC is a distance L, your C is a distance L from the axis for system B. So L squared. So I have here ML squared plus 3ML squared. This is equal to 4ML squared. Okay. Wait, sabi, ginaglase pa si Mama Babe, ha? And then, after this, we can now find the angular acceleration. So this is our goal, to find the angular acceleration. So in order to find the angular acceleration, we will use the definition of torque. So we can have torque is equal to I times alpha. Okay, so moment of inertia multiplied by alpha. So from this equation, we can get alpha equals torque divided by the moment of inertia. So pwede siya na ito makuha using this equation, the angular acceleration. But we're not given with the torque, but we know that torque can be obtained by using this equation. So R cross F, or we can just write this if R and F are perpendicular with each other. This can be written as R F. So if R is perpendicular with the force vector. So in this case, it is perpendicular. So this is your R. Muna siya imong force. Muna imong R, kining length diri and then muna siya imong force. Okay, so we can have this one, R times F. So we can get torque for system A. This is RA times F. So your RA is the whole length. So naakay 2L multiplied by F. So kini siya no? Since imong system A is kini na diri imong axis of rotation. So kini siya imo ang R, kining 2L. Alright. And then for system B, your torque is R sub B times F. So we have it's L multiplied by F. Okay. So kini siya nga length. Length of the lever arm. So this one. Your R is the length of the lever arm. So you have L times F. After this, we will get the alpha. So therefore, alpha for system A is equal to the torque 2LF divided by the moment of inertia for system A, which is 14 ml squared. So we can simplify this one. We have 1 over 7 F over ml squared. Ml. F over ml. Or you can just write this as F over 7 ml. Okay? And then for your system B, the angular acceleration is equal to L divided L times F. This is the torque, kini siya, no? Divided by the the moment of inertia for system B, which is 4 ml squared. So this can be simplified. You have 1/4 F over ml or F over 4 ml. Okay, so this is now, or these are the angular acceleration of the two cases. Okay, do you have any questions, guys? Do you have any questions?